So, just a quick side note about the tidyverse before we get started. So, the tidyverse is this set of packages that were developed by the RStudio group, and they all use a fairly consistent syntax, and they tend to be pretty easy to read and easy to work with. So they're trying to build out this consistent set of tools for doing data science for things like data wrangling and whatnot. Some of the packages that are included as part of the tidyverse are listed here. So we have dplyr, which is basic for data wrangling. We have tibble, which is basically it basically sits on top of data frames and manipulates them a little bit and makes some improvements, especially for working in the tidyverse. So tibbles are like special types of data frames that are defined by the tibble package. Some other ones, stringer is used for working with string data. Forcats is used for working with factors. ggplot2 is for graphing. So if you want to read in or install all of these packages, you can just use the tidyverse package, which was really like a meta package that calls all these other packages. Since all these tools are kind of built in or were generated by the people at RStudio, they're well documented within RStudio. So if you go, for example, to help and cheat sheets, you can find a bunch of cheat sheets for different packages. So for example, we're going to play with dplyr now. So I'm just going to open up the dplyr cheat sheet. Okay, so anyway, this is the cheat sheet. Again, we're not going to go over all of these. If you find you need to do something that I didn't show you, this is a good place to start looking to try to figure it out. Also, there's a pretty big user base online, so if you're trying to figure out how to do something, Google search and using things like Stack Exchange, Stack Overflow, or whatever, you can generally find some solutions to your problems. But this is a good place to start, and again, these are all just built into RStudio. Okay, so one thing I want to talk about before we get into using dplyr is this concept of the forward pipe operator, which looks like this. So it's percent, and then the greater than percent, and the percent greater than percent. So this is known as the forward pipe operator, and it basically allows you to pipe a data object or the results from a prior operation into a subsequent operation. So effectively, you can string a bunch of stuff together as opposed to just generating your code line by line. So in the tidyverse, the forward pipe operation tends to get used a lot. So anyway, you got to kind of get used to it, and once you kind of figure it out, it's actually very simple, and it does make your code really readable and much more concise. So I'm going to try to use that throughout the rest of the examples here. Okay, and then also that comes from this migrator package. I'm not sure how you say that, but it defines this forward pipe operator and some other piping operators too that we're not going to worry about. Okay. So since dplyr is not base R, you got to read in the package before you can use it. So I'm doing that here with library and dplyr. Note that I also could have done tidyverse, and that would just read in all the tidyverse packages. But I just read in dplyr here because that's the only one that I'm using. Okay, so now switching over to our dplyr syntax from base R. So basically So here, this is the same examples from above. So I'm trying to extract out all the counties that are in California or Oregon and that voted Democrat and have a percent poverty greater than 12%. Okay, so this is getting saved out to a new data frame. So basically, I'm taking the data object, I'm piping that into this filter operation, which comes from dplyr, and then within the filter, I basically am defining the query, and then that's it, and then that spits back the result. So filter is basically a replacement for basically the subset function we were looking at above, and then I just do my calculation of the percent, and as you'll see here, I basically get the same result as I got above. It's just using a different method. So one thing about the pipe function, what I tend to read it as then. So how I would read this is I would say grab the data frame, then pipe it into a filter operation. In the filter will be this criteria, and then that is the result that will get returned into the subset row option. Okay, so filter is basically used to select rows based on criteria. In contrast, select is going to be used to select a subset of columns. So here's kind of the same syntax here. So we're basically taking our data, piping it into select, and then we're just selecting out the columns that have these three names. So we're just creating a subset of 3 columns, as opposed to all the columns in the data set. And you can see now if we run in column that, we can see it's just 3 columns. Another note here, this dplyr : select. You don't if there's some ambiguity about where a specific function is coming from. So if, say, for example, you have multiple libraries or packages read in that use like the same function names, you can kind of get into trouble. So if you do the package name : the function name, it knows that it's the select function from dplyr as opposed to from somewhere else. This isn't always necessary, but it can be useful if you're worried about things being masked or having the same function used in multiple packages that are currently in use. Okay, so here's another example. This combines select and filter. So here I'm taking the counties, then piping that into a filter. I'm applying my filter, and then I'm selecting out just the 3 counties there that I'm interested in. So if I run that, I get back my results. So so we have 31 counties, 3 columns in the result. Okay, so another tool that can be really useful is summarizing. So summarizing allows you to calculate some type of summary statistic from the data. So here I'm trying to calculate the mean of the median incomes by county. So again, kind of the same structure here. I take my data frame, I pipe that into summarize, and then I calculate the mean of the median incomes and the standard deviation of the median incomes, and I print back the result. So this should aggregate the data into not an entire table, but just 2 values, the mean and the median. So note this average is going to be the name of the column in the resulting table, and this is going to be the result for the standard deviation column name in the resulting table. So if we run that, then we should just get back the average and the standard deviation. So from this data set, the average median income by county was 44,000, and then the standard deviation was like 11,000 and some, right? One thing you'll commonly see is combining this with the group by function. The group by function allows you to get summary statistics by group as opposed to by the entire data set aggregated. There's actually a similar group by function that's built into like pandas in the Python environment. Okay, so let's have a look at that. So here, again, we're taking our counties, we're piping that into group by, and we're grouping it by subregion. So these are the different subregions or parts of the country. It's like New England, Mid-Atlantic, Mountain, Pacific, Southeast, stuff like that. Okay, so we do a group by the subregion, then we get the average and the standard deviation, and then we print that back. There we go. So now instead of getting these global statistics, we're getting statistics by each subregion in the data set. And then the standard deviation. Okay, real quick, I just wanted to, let's just edit this a bit. Let's say we only wanted it for a couple of these. So we could do that by doing a filter. So we could do something like, we could add in here filter, and we would do where sub region is in a list. So we'll do % in %, and then C to get a list here. So we'll just do, let's see what our options are here. Let's just do New England, or Pacific, or we'll do Mid-Atlantic. And then that result will get piped into the group by. Okay, so let's see if this runs. There we go. So now we're just getting those 3 regions. So in summary, I basically piped in the data into a filter. I filtered out just these 3 subregions. Then I grouped by the subregion and then calculated summary statistics. So I got 3 separate summary statistics grouped by region. Okay, another useful function from dplyr is count. So this allows you to count the number of records that are in a table, for example. So, and also by group. So what I'm doing here is I'm basically just counting the number of counties that are within each subregion. So if I run this, I get the county counts by subregion. Now, what I could do is, if I didn't put in a group by here, just get rid of that real quick, then I would get the total count. So there was 3,109 counties in the data set, and if I add the group by back in, oops, then I get them by the type. I could also do something like get it by the state, right? So if I could do, we'll do group by, and then we'll do group by state name. Nope, something didn't work. Oh, actually, this doesn't need to be in quotes, so I just forget that. So there we go. So now we have a list for every the number of counties in every state. Okay, mutate and transmute. So mutate is used to add columns to a table, and transmute is basically used to add columns to a table and drop the original columns that were used to calculate it. I'm mainly just going to demonstrate mutate here. Okay, so here my goal is to calculate the percent of the population that did not vote Democrat, and so that's the sum of the percent Republican and the percent other. So we're basically just going to add those two together. So again, I take my counties data, I pipe that into select, and I'm just pulling out a subset of the columns here. And then I pipe that into, what happened here? Oh, I must have hit something, because that's, let me fix this real quick. I must have accidentally hit something. And then that goes into mutate. This is going to be the new column name, and then this is the operations that's being used to create the values in that column. What did I do? Unexpected. Oh, actually, yeah, that was the issue. There we go. So that would produce that result. And then if I just did head counties vote, then I get back those results, and you can see the percent not dim is just these two added together, right? So that's mutate. You can use that to create new columns in a data frame. All right, so this section explains how you can use dplyr to do random sampling from a data table. So selecting out random rows from a data table. So the sample in function is used to create a random sample. If you set replace equal to false, then that means that it's random sampling without replacement, so you can't double sample the same row. If you set replace is equal to true, then that's random sampling with replacement, so you could theoretically double sample a row. Okay, so that's what that does. And then if you want to do like a stratified random sample, then you can group by and get a certain number of random samples by group. So in this case, we're going to get 15 random counties selected by subregion, so 15 in each subregion, and replace this at default. So this is stratified random sampling without replacement. And then I'm just counting to make sure it makes sense. Let's just run that then. Okay, oh, there's multiple outputs. So this first output here is, I said randomly select 150 counties from the data set, and we end up with a new table that has 150 records, so that makes sense. Here we get a 0.2, sample fraction means sample 0.2 or 20% of the data. So this, I'm calculating the percent there. You can see there's a little bit of a rounding error because the number doesn't go into, I guess, 20% of the data is not a whole number. And then this is the last result here, and you can see we got 15 records for each subregion. So anyway, I use dplyr a lot for creating random samples, like for statistical analysis and whatnot. Okay, binding stuff together, right? So these are operations I use a lot. Bind rows is basically used to combine rows together. So if you have two tables that have the same columns, you can combine them into a single table with more rows. So if you had 10 rows in table A and 15 rows in table B, and they all have the same columns, you can get back the table with 25 rows in it. And then bind columns basically is if you have the same rows and it binds on new columns based on the order or the index. Now, I'm not sure why I've got a... Let's see what the issue is here. If it gets, I don't know why it says there's a warning there because it ran. So in this example, I filtered out just the counties that are in Maine and just the counties that are in Virginia, or sorry, Vermont, and then I merged them back together into a single data frame that has both sets in it. So add those together, you get 30 overall, and that was done with this bind rows option. And then this is an example for bind columns. Here I'm pulling out a subset of columns into two separate data frames. So they have the same number of rows, but different columns. And then if we run those, if we bind those back together, then we can get back all the columns back in the same place. That's kind of a dumb example because they were all in the original table, but this is just showing you that you can combine them together. One thing you got to be careful with this is it's just simply doing it based on the index. So each row is assumed to be in the same order, or the rows are assumed to be in the same order. If you don't know if they're in the same order, then it's better to use some type of like table join, which we'll talk about later on here in this section. Okay, so some other operations that involve working with multiple tables. Intersect is used to return all of the records that are the same between two tables. In contrast, union is used to return all the records of both, even if they are the same or if they're different. And then setdiff is used to figure out or find the rows that are in one table but not in another. Okay, so here's an example of using setdiff. So here I'm basically creating a set of data that I'm calling train, and then a set of data I'm calling test. So this is a common use case. This is where you have a data set and you want to break it into two pieces to train a model and then to test a model. So if you do any like machine learning, you'll have to eventually do this. So the training set is used to train the model, and then you evaluate the model on a set of withheld data, which is the test set. So basically what I'm doing here is I'm pulling out 75% of the counties stratified by subregion to be the training set. And then I want to have the remaining counties be separated out to test the model. So to do that, I use setdiff. So basically I find all of the rows, or counties in this case, that are in the county sub data frame but not in the train data frame. So those are the ones that were not selected. So if I run those, there's 2,332 counties that were put into the training set, and then the remaining 1,450 are in the test set. Again, as I mentioned above, joins or doing a bind columns assumes that the rows are in the correct order. They match up based on order. If you don't know if that's the case, then that can give you incorrect results. So instead, it might make more sense to join them based on a shared common field. So this is the concept of like a primary and foreign key if you work like with databases, for example. Okay, so there's a couple different types of joins available. So a left join is going to maintain all of the rows in the first table, even if it doesn't have a match in the second table. A right join is the opposite, so it'll maintain only the rows that have a match in the right table, and then also all the rows in the right table. Inner join is when you just get back the rows that have a match in both tables. Full join maintains everything, even if there's no match. And there's a few others that are listed here that, frankly, I never really use. The ones I tend to use the most are a left join and an inner join. Okay, so here's an example of that. So I'm selecting out just the county and the FIPS code for the county, which is a numeric ID for the county. And then I'm pulling out the FIPS code, the median income, the percent greater than 55 years old, and the percent poverty rate. And then I'm using a left join to join together those two tables based on the FIPS code. So basically they share a common field, this FIPS code field, and that's a unique identifier that you're using to match up the rows, as opposed to just assuming they're in the same order. Okay, and that's basically that. So that's a quick introduction to dplyr. Again, if you want to learn more about dplyr, definitely have a look at the cheat sheet for dplyr, and there's tons of cool help online. There's lots of other cool functions that we didn't have time to talk about, but the syntax works pretty similarly. If you do use dplyr, make sure you make use of the pipe function, the forward pipe operator, and that you use it to make your code a lot more readable and concise.